So what are you guys?
We're part of the Swartwood family.
Let's look at this quiz. Val drives for 2 hours at 30 miles per hour and then 1 hour at 50 miles per hour. What is his average speed for the journey? So this is definitely sort of a DAT classic, right? So if you want to look at this, you can do this as a weighted average, like from probability and stats. But I think, let's actually make this a little sharper here. Oops, wrong way. But I think we can also do this as distance is rate times time, okay? And we'll kind of do it two pieces. So distance 1, rate 1, time 1. And then this distance 2, rate 2, and then time 2, okay? In fact, I'll make it even sharper. Okay. All right, so for the first leg of it, what's he going to do? He's going to travel some distance, right? He's going at a rate of 30 miles per hour, and he's traveling for 2 hours. Or so it's easy to see that the distance is 60, right? In the second round, we get his rate is what, 50? He only travels for 1 hour, so he covers 50. So the total distance right now is going to be 110, and that's definitely equal to the rate that we're looking for times the total time, right? Let's call that. Okay. All right, so it's going to be 110 is equal to the rate we're looking for times the total time, which happens to be 2 plus 1, so 3 hours. Right? Does everybody agree? So 2 hours here, 1 hour there, 3 altogether. Okay. All right, and then the rate here is going to be something like 30. Oops, why did it do that? Let me erase this. So it looks like it's going to be 30. What? 6 2/3, I believe. Right? Yeah, that looks about right. Okay, so B looks like it. Okay. All right. Not too bad, right? Just an application of distance is rate times time. We worked it as two different pieces and then we put them together, okay? Well, let's try another one. Similar theme, another classic. Relay drives to work at 100 miles per hour, then drives home at 60 miles per hour. What was his average speed for the round trip? Okay. All right, so this one's a little bit different. We're gonna have to pick some sort of distance here. So again, we could do this abstractly, but I want it to be concrete. Since we're dealing with 100 miles per hour, like we talked about in class, 60 miles per hour, I think since we're going to divide into this, you'll see in a sec, we're going to pick a number that's a multiple of both. Oops. And maybe, I don't know, 300 looks good. So we'll pick our distance to be 300, okay? So kind of like the last problem, we'll do it in pieces. Okay, so on the way there, the distance is 300, right? The rate is going to be 100. And it's clear that the time is 3 hours, okay? All right, but what about on the way back? So on the way back, distance hasn't changed, it's still 300, right? The rate now is gonna be, I believe, 60, and the time we don't know. So we're gonna solve for that time, and I think get 5. Okay, so now we have this and this. And now I'm gonna do it one more time. I'm gonna clear this right here. This is one more time. Okay. So let's switch it up. Maybe orange. Distance is rate times time. The total distance covered is going to be 600. The rate is what we're looking for, but the total time is now 3 plus 5, which is going to be 8. So I think the rate is something like, I don't know, 750. Okay, wow, 75. Okay, that turned out much nicer than I thought it would. So 75 it is, right? So again, another application, right? But we're thinking what? Do it in pieces. Distance is rate times time. Piece 1, piece 2, put it together, okay? All right, let's look at number 3. So Njal can make 30 burgers in 4 hours, while Gunnar can make 50 burgers in 6 hours, okay? How long will it take both working together at their respective rates to make 190 burgers? Okay, so Gunnar, however you want to pronounce them. So one is making 30 burgers, I think in 4 hours. And the other is making 50 burgers in 6 hours. And now they're going to work together. So how long is it going to take them to make 190 burgers? Okay. So one thing to note here is first, make sure you can do this the traditional way, which basically becomes a distance is rate times time problem. But first, the distance, right, would be what? Well, let's write it this way. And let's do this for Njal. Okay, so distance would be he gets 30 burgers done. The rate we don't know, The time is 4 hours. So you can see that his rate is, I'm going to divide both sides by 2, make this 2, make this 15 just so it looks cleaner. So 15 over 2. Then we do it again. This time we're going to have 50 is equal to what? The rate, which we don't know, and the time, which we said was 6 hours. So RG, again, I'm going to divide both sides by 2. This will make it prettier. So let me erase this, right? So it's going to be 25 and 3 over there. But we said the rate's going to be 25 over 3. Okay. This is the rate at which they produce stuff, right? But now they're working together, but they're going at their independent rates. So the total rate would be what the first guy can do plus what the second guy can do, right? And that will give you the total rate. And then the distance would be 190, right? So distance is rate times times, and this would be our rate. I mean, if you've come this far, I might as well just solve it. Times the time, okay? I guess the common denominator here would be 6. So I'll multiply this side by 3, right? And get 45. And multiply this side by 2, top and bottom, and get 50. It's going to be a pretty number, I think, even though this looks really painful. Let's keep this going. So that's going to be what? 95 over 6 times t is equal to 190. Okay? 6 over 95 is equal to t. Multiplying both sides by 6 over 95 to cancel on the right and to get this on the left. Okay. Divide top and bottom here. I think 95 goes into 190 2 times, right? And then 12 is equal to the time. Okay. All right, so that's it. Now, this is okay, and there's nothing wrong with knowing the procedure. But again, if you're going to do it this way, you could skip it if you think it's too tedious, and then come back. Mark an answer and then come back. But I just want to show you how sometimes the DAT frames, because that thing's supposed to be super computationally heavy. So probably, well, there might be a slicker way to do this. We know answer is going to be 12, right? Let's keep that answer down there. And let's do this one more time, okay? But this time we're going to do it this way. First, I'm going to try to cancel out here. So 2 hours, 15, right? Because if you can do 30 burgers in 4 hours, then you can do 15 in 2, right? I'm just canceling out common factors here. This will be 25 and 3. Okay, now let's come back and rework this. So the thing about this is the pain in the butt is this and this don't agree. So I'd like them to agree. Almost like we're getting a common denominator. I'm going to multiply this whole thing here by 3. And that'll give me the count. Let's erase this right here. Right? That would give me the count for 6 hours. So in 6 hours, what can we do? Well, we can do 3 times 2 here. Well, we have 3 times 2 hours. So we can do 3 times 15 burgers. So 45 burgers in 6 hours. Then on bottom, multiply everything by 2. So again, we'll have 6 hours altogether. But now we'll have 50 burgers. Okay? You can see it's following a similar pattern to what we did before. So it's the same idea. So we'll get 95 burgers done if they're working together in 6 hours. But our target is 190. And you can see there the relationship is this guy is double. 190 is double 95. So if you need double the amount, you need double the time. Right? And of course that would take us to 12. Okay? All right. Let's try another one. Anyway, my bad. So the recap is we can do it our traditional way, which really distance is rate times time. That totally works. Okay? But if the problem seems really tedious, it's probably a cheaper way out. In fact, in this problem, we pretty much did it the same way. It's just that organizing in this fashion, like we did over here, might make it more transparent. Okay? All right, let's try it again.